Both post whatever notes I come up with as PDFs or whatever, and I'll record the lectures, and those will be actually uploaded to YouTube, and I'll have links on the website. All right. So let's talk about the details of the class. Okay. So like I said, you got to read the syllabus. That's where all the details are, and if I forget something, it'll be in there. Right? So let's think about the materials first. We have the e-text, right? So again, you've got to have access to that. As I understand it, last semester you were granted access to the study guide and solutions manual, and I've been told that you should continue to have access to that. All right? iClickers we're going to use for extra credit. I'll talk about those in just a minute. So if you want the extra credit, then you need to have either the iClicker or have the app, Reef app on your phone or your computer or your pad or something like that. And back in the syllabus, under iClickers, it has some links to go and register all that stuff. Tells you how to do all that stuff. Okay, so one of the main ways to get content in this class are going to be the lectures. Okay, I already told you about the pre-lecture notes. Okay, so those are the note outline. I will post the post notes, what I've annotated, and then, like I said, I'll post the lecture videos. iClickers, what we're going to do is I'm going to have probably one iClicker per class. It can be at any time during class. They're going to be worth 2 points, one for getting it right, one for just being here. And for extra credit, you can do them all, but you can only apply a maximum of 20 points over the semester as an extra credit. Okay? So you can, if you miss one, it's going to be okay. We're going to have a lot more than that. But you will have to register your iClicker in order to do that. Okay? Your sequence in studying, what I would recommend, is that you might want to look at the learning objectives just so you know what's coming up, and I'll be posting those on my slides. We are going to have Learn Smart reading assignments, and so these are in the Smart Text and the e-text that comes with our text. And these are going to be 20 points each. All right? And they're you get 20 points if you complete it. All right? And for me, I don't know how many of you used it the way it is. I think they're actually kind of fun. But, that's me. I'm like the kind of guy. But I've worked through each one, and for me, they seem like a really good way to get introduced and to learn that material. Because if I work through it, then I basically know all the stuff that's in the chapter. By working through it one time, and then I'm like done. I can ace the exam, all of that kind of stuff. So I think these are really good to do. We're also going to have 2 types of assignments. One I call practice problems, and these are both on Connect. Practice problems are multiple choice types of problems. Okay? You get 10 at a time. You can do it multiple times. It'll save your highest score. All right? These are worth 10 points each. And then we have what I'm calling application problems, and these are going to be more involved problems where you might have to draw structures, draw arrows for mechanisms, all of these kind of things. And likewise, those are 10 points each. All right? We will have a Learn Smart for each. These are organized by chapter, and you need to complete those for each chapter before the exam on which they're covered. Okay, so our first exam will be chapters 13, 14, and 15, and you need to finish all 3 of those before we take exam 1. Okay? But they're associated with the chapters. The practice problems and the application problems, these are weekly. Okay, and they will start at 10:30 or 11:30 a.m. on Monday, right after class, and they will close at 10:30 a.m. the next week. All right, so you have 1 week to do those. Okay, so don't save them to the last minute, because if you know, like, oh, Dr. Davidson, you know, my computer died or something like that, I'm going to say, oh, too bad. You know, you should have done it a few days ahead so you'd have multiple tries. For both of these types of problems, I will drop your one lowest score. Okay, so you get one bonus one. Okay, any questions so far? Yeah.
Is it just one attempt on those practice and application problems, or will we have to...
No, both of those you can do multiple times. Hopefully they're set up like I think they are. The way they're meant to be is that you can take them multiple times. I think usually on a given problem you can have 3 tries within one attempt at the problem set or whatever. But then after you finish that, you can go back and take it again, and they're actually drawing from a much bigger library of questions. So it is to your benefit to do these multiple times. Okay? So don't just do it one and, oh, I got 10, I don't have to do that anymore. The more you do them, the more questions you'll see, and the more it will help you. Okay? Any other questions?
And that's the same for the Learn Smart reading questions?
No, the Learn Smart are just, you get the points if you do it or not. You can go back and study in it, but you don't, Learn Smart is set up so the questions they give you depend upon how you answer them. So if you miss some questions, it'll give you either those same questions or similar questions again to make sure that you're, getting good on that part you missed. But those are just kind of a one-shot thing, 20 points, yes or no, if you complete it. Okay? Is there another question?
On the practice and application problems, is the grade taken as the highest attempt or the last attempt?
The grade on these 2 practice problems and applications should be the highest score. Okay? So, there's no reason not to get maximum score on every one of those. Okay? All right. Okay, the exams I'm going to do a little bit different than what you've probably had before. Okay, there's 2 parts to the exams. One is the written part, and this is going to be in class. We're going to take this in class. All right, and I'll probably split us into more than one room to do the written part. And these are going to be problems where you have to draw out mechanisms, you have to do predict the product of a reaction, or what should be the reactant to give this product, draw a synthesis. I tell you, you can start here and finish here. How do you do this? So this is going to be the written part. We're also going to have a computer part, which you're going to take at the testing center. Okay, so usually the written part will be probably 4 problems. Okay. The computer part is going to be, well, not all multiple choice. It could be multiple answer, or it could be some other variations that they give in Canvas, but this will have 25 problems. Okay, you'll have an hour to do 50 minutes to do the in-class and an hour to do the 25-minute one at the testing center. Now, the thing that's even different from this is, I've been using this for quite a few years, is that we use what I call a self-correcting approach to the computer part of the exam. Okay, and what that means is after the 2.5-day testing window is closed for the main test, I'll open up another version of that test, and you have about 3 more days or so to redo it if you want. Okay? You can redo it using any resources that you want, other than me or other professors or UTFs or SIs in our class. You can get together and study with your classmates. You can use the textbook. You can go online. The idea here is that if you were unsure of things on the first time, you can redo it and try to figure it out. Okay? In the end, I'm going to take your score on the first try and your score on the second try, and I'm going to average those. And that's going to be the computer part of your score. So the total score, it'll kind of work like this. So we have the written, and And I think the way that this works is this is 100 points. Okay, for the computer, you're going to have number 1, you're at try number 1, you're going to have try number 2, we're going to take the average of these, and that's what's going to apply here, and it's going to be 100 max as well. All right, so then you have a 200-point maximum for the exam. Okay? Yeah.
Are you required to do the self-correcting portion?
No, if you don't want to do the second part, you don't have to. But unless you think you got 100%, then, you know, there's not really any reason not to do it, unless you think you got almost everything right, and then when you use all the resources available to you, you're going to miss most of them. Could be, you know, you could have your classmates convince you to change your answers and change them to wrong. I just average them, so yeah.
So the second time we take it is not in the testing center?
Correct. The second time,
So
it'll be the same format, but you'll go on Canvas and do it, but there's no security or anything. You can just do it on your own whenever. Yeah, question?
So will we be notified of our score after we do the test?
Oh, that's the important part of this, is that no, you won't know what your score is. You won't know what you got right or wrong. The key thing is you have to look at the questions and you have to decide, do I want to keep my first answer or do I want to change it? Okay? Yeah.
So will the questions on the second test be identical or different from the first?
The questions on the second one will be identical, but the answer order might be different. Okay? And you'll have to remember kind of, when I used to use all Scantrons and I let everybody just, you know, write it all down and record what they have it now, since it's a 2.5 day window of taking it and it's on the computer, I can't really do that very well. Yeah, and back.
Is there like a time limit on the second exam, on the second attempt?
Yes, there is. So the way that I've got them set up right now is that all the exams are on Mondays. The written exams are on Mondays. And once we leave our exam on Monday at 11:30, the first attempt will open up at the testing center. Okay? You'll have from Monday after class until Wednesday night to do the first attempt at the testing center. When that closes, the second attempt will open. All right? And that will go through essentially midnight on Friday. Okay? So that'll be the schedule for each of the exams. When it gets to the final exam, you know, I think about this second attempt as like your training wheels, right? When it gets to the final, you got to take off the training wheels and ride without it. So there's no second attempt on the final exam.
So the second attempt will be an hour or just unlimited?
The second attempt is unlimited until you submit it. You can go in and out and in and out. You know, you should probably, but once you submit it, then you're done. Anything else? Well, you know, we'll go over this stuff again before we get to the exam as well, for sure. Okay? All right. So for extra credit, we have a few things. Right now I have set up a pre-test, and what this does is kind of test how much you know about this class already. Okay, and it's kind of a way for us to assess teaching. It's like one of the standard ways, but it always seems like kind of dumb to me, because in the beginning you shouldn't know much, right? You haven't had this class before. And afterwards you should know a lot more of it. So just take this, don't worry about your score, okay, because you probably don't know this stuff. And you'll probably get, it's out of 5 points, you'll get like, and each one, there's 10, each one is a half a point, maybe you'll get 1 point or something. Okay? But after you're all done, don't worry about that. After you're all done, I'll change everybody's scores to 5. You get 5 points extra credit for completing the pretest. Okay? Also, I have this synthesis review. Okay, and this is just a question from each of the chapters you covered last semester, kind of to dredge up the old material. On that one, you can earn a maximum of 5 points, but you get whatever score you get. Okay? So those are going to go through, they're open now, and they'll go until next Monday. So if you want those scores, then do them before next Monday. Another thing that I'll have is I call it the molecule of interest. And so for each exam, I'll post a link to some different molecule of some special interest, some application or something. And I will put a 5-point extra credit question on the written part of each exam that is covering some aspect of this molecule of interest. All right, so you can go and look at whatever link that is, read a little bit about it, and then I have an extra credit question on it. Okay? And then the last thing, so those are 5 points each, so that's a total of 20 points total, 5 points for each exam, 3 exams and a final. And then there's the clickers. I think I'm giving too much extra credit. I know, but then I'm going to have to make the exams really hard. The iClickers have a total, like I said, of 20 points that you can earn. Okay? So one thing to be aware, this repeat on the exam, to make it work well, I have to make the computer part kind of challenging. Right? If it's too easy, then that second try doesn't do you any good. Right? Okay, any questions? Okay, there's probably going to be things that come up. We'll go over these things some more as we go through. You can ask me whatever, okay? I'm still not. Oh, yes, I am. All right, so let's look at a little preview of what's coming up. Okay? So these are the chapters in our text. We're going to start out, like I said, by doing something really different than anything you've done up to now. And this is going to be 2 chapters, 13 and 14, on what we call organic structure determination. All right? So up to now, you've learned all these reactions. You say, you start with this alkene, and you add HBr, and you get this bromo compound. It follows Markovnikov's rule, all this stuff. But, I told you, your professor told you that that's what happened. But if you're in the lab doing it, how the hell do you know that that's really it? Right? If you're doing it in the lab, you got to figure it out yourself. If you got a ratio of compounds, 3 to 1, like it says in the book, in the lab, you'd have to separate those, and you'd have to independently determine what their chemical structures are. Okay? So in this part, we're going to learn some techniques that are used in the lab to do that. Okay? And these are all instrumental techniques. They use various big instruments and stuff. Each one gives some kind of a graph, and we have to learn how to interpret those graphs. Okay? So in the end, what we'll try to do is I'll give you these different pieces of data, and you'll have to propose what molecule would give that data. Okay? So it's not only, I'll give you tables of data to look at, but it's not only just repeating something that we've done in class. You're going to actually have to use your imagination. I know, and that's hard. This is the stuff that I used to do all the time, though, in this natural products chemistry. So I like it. It's just puzzle solving. Right? You have different data. You got to put it all together. Okay. After that, we're going to talk about another thing that's a little different. You've done lots of chemical reactions, but we're going to talk about reactions that proceed through radicals as intermediates. So remember, radicals are molecules that have an unpaired electron. All right, so they're going to have a different kind of mechanism. Okay, after that, we're going to talk some more about structure, about resonance, all right, and its implications on some reactions you've learned before. And then we're going to start going into some different functional groups, okay? We're going to talk about aromaticity. That has to do with things like benzene. Everybody remember what benzene is? So benzene is this 6-membered ring with alternating double bonds around it. super stable, and because of its stability, it has a completely different kind of reactivity than other alkenes. Right? I think of it as being kind of a magical alkene. It has different properties. And then look at this. We've got 6 chapters talking about carbonyl compounds. Remember, carbonyl compounds are molecules that have carbon-oxygen double bonds. And these are super important. But I've never seen a text that had 6 chapters on it. Usually it's 3, but they broke it up into smaller pieces. All right, and that will probably scramble your brain. We'll have lots of reactions. Then we're going to talk a little bit about amines, and then if we have time at the end, we'll just do a little intro to some of the biological molecules, like amino acids and proteins and things like that. All right, so that's where we're headed. What kind of problems might you see in this class? Okay, in the beginning, remember we're going to see these problems where you have to utilize some kind of data, some kind of graph to determine a chemical structure. All right? So these are the ones that take some more imagination. We'll have reactions where you have to either predict products or reactants. We'll have reaction mechanisms, right, where you have to draw arrows showing the movement of electrons and everything like that. And we'll have synthesis problems, okay? And these will be essentially something like, I think I wrote some of these down in my notes, some ideas. I forgot everything here. No, I didn't write anything down that. But you might say, okay, I want to start, forget it. Oh yeah, here, I had one. I'm going to start with this alkyne, right? And I want to convert it into, you probably saw this one before, this is too easy, this ketone. Okay, so you'd have to map out a sequence of reactions to do this. Okay, now I haven't tended to give tables of reagents or anything like that, right? And so you should go back and practice some of these. Usually the reagents aren't worth a lot of points, but the more you practice these, the better off you're going to be. We'll talk about this more as we get going. One of the best ways to practice synthesis and practice reactions is to even make up syntheses like these on your own. Right? It's just a fun thing to do in your free time. Because if you put yourself in my point of view, I have to think up some synthesis for a problem or for an exam or something. Think about this. What if you're thinking up syntheses and you just happen to think up the exact synthesis that I put on the exam? Now, wouldn't that be great? What would be... Okay, so how do you organize all these reactions? So one of the most important things in this class, really, in order to remember all this material, is to be organized. You have to have a way to organize it. And you've seen quite a few reactions so far, or you thought you learned a lot of reactions already, right? Well, they kind of explode when we get into the second half of this class, right? And so it's important to try to have a scheme to organize it so you can continue to build upon it. All right, and the way I think about it is that there's 3 ways, you can come up with other ways as well, to study and to organize and to write down your reactions. One is to write them based upon the reactant functional group. Okay, and this is kind of how we learn them in the different chapters, right? So for example, what if we just chose some functional group? Let's choose an alcohol. And then you ask yourself, what can I convert that alcohol into? Right? And we could make some kind of a table here. You could be like, oh, what can I do to this? Oh, I could do, well, you tell me, what can we do to this alcohol? Huh? We could do a dehydration? Yeah, we could do a dehydration. Double bond. What else could we do? I can't hear you guys.
Sorry, you can convert to an alkyl halide?
Yeah, alkyl halide. Yeah, you guys are coming up exactly. Somebody, can you see my notes or something over here? You're doing it exactly the same order as I had them. Right? We could make it into a nucleophile and use it as a nucleophile. So we could maybe add another alkyl group over here, right? SN2 substitution. We could do an oxidation reaction, right? We could convert it to either an aldehyde, which we could also convert to a carboxylic acid, right? And so these are kind of thinking about this in a synthetic point of view, right? Going in a forward direction. What can I turn this into? Right? The second way you might do this is more of what we call a retrosynthetic approach. And it's thinking about it in a backwards sense. So in this case, we might say, okay, let's start with the same thing like this. But the question is now, what can I make this from? Okay, we're going to do it backwards. So, maybe we could make it from this alkene, right? So how would we do that? So what's the general reaction? It's a hydration, right? But we want the OH on this less substituted side. So how do we do that? It's the hydroboration oxidation reaction, right? We could also make this, we could make this from a halide. Some halide like this. We don't have as many ways to do this so far. But if you start something like this, make up some molecules like, how can I do this? As we go through more chapters, you might come up with new ways to do that. You just add them to the same diagram. Okay? The other thing, like I mentioned before, is synthesis. And synthesis is, works for a specific kind of problem that we do, but it's also another way you could study. Right? You could just pick a molecule and think about, what can I turn this into? Right? I think about it sometimes as being like you could just do the endless synthesis. Pick a starting material and just convert it to something, convert it to something, convert it to something. Just keep going. Right? Or in your study group, each of you come up with a short synthesis and test each other on it. Right? Things like that. The more you kind of investigate the whole synthesis landscape, the better you're going to be. Okay? All right, more here. All right, so let me just give you one slide of intro. We've just got a few more minutes here. So this is a little bit of an intro to the first two chapters we're going to look at. All right? So they have, like I said before, have to do with organic structure determination. All right, I've listed 4 techniques here. In fact, we're only going to talk about 3 of these. This one here I included in my table here, but we're not going to really cover this one. Okay? So look at the 4 different techniques and tell me what's one thing that's different. There's one of those that is different than the others. Well, they're all different from each other, but there's something particular that's different about one where the other ones are similar. Look at the end of each technique. Okay, the first one is mass spectrometry. The next one is infrared spectroscopy. Then we have ultraviolet visible spectroscopy. We have nuclear magnetic resonance spectroscopy. All right, so what's the one that's the outlier? The first one, right? Spectrometry. So spectroscopy involves any technique where a molecule is absorbing light. Okay? And what we'll learn, we'll go through all of, an introduction to these on Wednesday, but each of these techniques are different because they absorb, the technique involves the absorption of a different energy of light, or different frequency, or different wavelength of light. And when a molecule absorbs a different energy of light, it causes that molecule to do different things. Okay? So we're probing the molecule in different ways. And each one of those ways will give us some different information. And in the end, each of these techniques will give us some information that's complementary to the other techniques, right? So that's part of our goal, is to learn how to put all of that together. All right? So I will see you guys Wednesday. Make sure to get into Canvas. Do those extra credit problems, look around, and then let me know if you have questions.